session today. So a very warm welcome and welcome to a very unique topic that you may have not learned in school, which is English of Mathematics. So English of Mathematics is a very unique thing, and you can all lower your hand because I will be going to ask you another good question very soon. So please lower your hands. Okay, so my first question to all of you is that how many of you like or love to study maths? Just raise your hand quickly. Okay, Arman Hussaini, and of course, Maham, our teacher. Okay, that's great. Very good. So everyone is present and everyone is listening, and there are few okay, let me check who doesn't like maths. Of course, in the participant list, I can see their names, and in the bottom we have Sumaya Sheikh, Rafa Siddiqui, Umar Qutbi, Meheran Qasim. They don't like maths. Oh, Maham has lowered her hand down, and Lisa Nadeem. Okay, so I can say like 50% of us like maths and 50% of us they don't. Okay, now math is a very important language because we have like math is not a subject, math is a language. Why I'm saying that math is a language? Because it is a human way to understand many things. But unfortunately, in our schools, we make it very complicated, and most of the students are so horrified that they start hating maths. So today, inshallah, we will be doing something that will make you enable to love maths, and you will know that math is not only a subject, math is not only something that in which we keep on going calculations and all, but math is something that that is a human language. So first of all, you should know that math is not a new language. Math is very old. I'm just enabling your mics. Okay, Sayyid Osama Nuri says that he like maths partially. It's okay. Okay, now I'm just allowing you to unmute yourself, but just tell me, what do you think? How old is the history of maths? Can anyone answer? 100 years ago, 200 years ago, 1000 years ago? How old is it?
5,000 years ago.
I guess it's 1,000.
500 years
Okay.
ago. 500 years
I guess
ago.
1,000.
I guess 2,000.
900.
Very nice.
I also guess 1,000. 1,000.
Very nice. Okay.
1,000.
500.
1,000.
2,500.
Okay. Thank you so much for all of your answers. Let's see how old it is. Now we will see how old it is. Actually, what happens? Yes, of course, the math started when I think the first human being came into Earth, because we can like Allah has taught the Hazrat Adam alayhi salam all the numbers and everything, and like he educated Hazrat Adam alayhi salam with everything. So we can say that it is of course very old as human civilization. So because why we don't love maths? Because it's just because of the numbers we are studying, and it sounds very complicated. Of course, we are afraid of word algebra. Just 1 minute. Okay, so because we are why there is some issue. So because we are afraid of these words like algebra and trigonometry and calculus, that's why we don't like math. We don't like our math teachers. Our math teacher look horrible. We don't like her face. So that's why we don't like math. But if we connect the math to humanity, we will see that math is not an unhuman language. It is a human language, and people in the ancient days, they started communicating, and they do have their own units, and they have their own connections with math. So there is a quotation by a famous scientist, Galileo, that universal language is written in maths. So the maths is very beautiful, and when we try to connect maths to our daily life, we automatically build the love of maths. Now, what is the most, because I can see that most of the students belong to middle grades. Now, again, I'm just unmuting, and tell me what is the most difficult topic for you in maths. Okay, one by one, you can raise your hand. Please raise your hand, I will ask you then. Okay, I will see that who has raised the hand first. Okay, okay, Saqib Noori, which topic is most difficult for you in maths?
Multiplication.
Multiplication. Okay, Arman Hussaini, what is your which topic is most difficult?
For me, it's geometry.
Okay. Okay, Fatma Junaid, what is your difficult topic in maths?
Division.
Division. Okay, I got the multiplication, and we got geometry, and we got division. Yes, Anam Farooq, what is the most difficult topic?
Division.
Division. Okay, division is winning. Anyone else with division? Yeah, Aisha Adi, did you answer?
Geometry.
Geometry by Ibrahim. Okay, and we have, let me see, Anam, I think Anam has answered. Okay, Meher Furkan.
Geometry.
Oh, geometry is winning. That's great. Qasim.
Division.
Division. So we have a tie between division and geometry. Let's see who will win. Okay, now I will ask one more person. Yes, Fatma Hassan. Yes, Fatma. Sorry?
Division.
Okay, so division is the winner. Please clap for division. Like, Alhamdulillah, division is the winner. So, okay, now let's see why we don't like division. We don't like division because we are having difficulty in multiplication. And like, for example, let me share my whiteboard. Like, for example, if I say, okay, like division, we started with a very small number like 36, and I would like to divide it by 2. So the answer is, okay, because it's an easy thing, so I'm writing myself. Just because we don't understand the language of mathematics, so that's why it is difficult. But 2 times 18 is 36. Okay, but of course it was just something that I was just asking because I want to know the difficulties. But in the real scenario, first I would like to show you a video about the brief history of numerical systems. And after that, I will, at the end of the session, we have a quiz which is optional. Anyone can take it. And also we will, I will ask this question again, that do you still love or hate maths? I will ask you in the end. Okay, so here it goes, a brief history of a numerical system.
3, 4, 5, 6, 7, 8, 9, and 0. With just these 10 symbols, we can write any rational number imaginable. But why these particular symbols? Why 10 of them? And why do we arrange them the way we do? Numbers have been a fact of life throughout recorded history. Early humans likely counted animals in a flock or members in a tribe using body parts or tally marks. But as the complexity of life increased, along with the number of things to count, these methods were no longer sufficient. So, as they developed, different civilizations came up with ways of recording higher numbers. Many of these systems, like Greek, Hebrew, and Egyptian numerals, were just extensions of tally marks, with new symbols added to represent larger magnitudes of value. Each symbol was repeated as many times as necessary, and all were added together. Roman numerals added another twist. If a numeral appeared before one with a higher value, it would be subtracted rather than added. But even with this innovation, it was still a cumbersome method for writing large numbers. The way to a more useful and elegant system lay in something called positional notation. Previous number systems needed to draw many symbols repeatedly and invent a new symbol for each larger magnitude. But a positional system could reuse the same symbols, assigning them different values based on their position in the sequence. Several civilizations developed positional notation independently, including the Babylonians, the ancient Chinese, and the Aztecs. By the 8th century, Indian mathematicians had perfected such a system, and over the next several centuries, Arab merchants, scholars, and conquerors began to spread it into Europe. This was a decimal, or base 10 system, which could represent any number using only 10 unique glyphs. The positions of these symbols indicate different powers of 10, starting on the right and increasing as we move left. For example, the number 316 reads as 6 times 10 to the 0th power, plus 1 times 10 to the 1st power, plus 3 times 10 to the 2nd power. A key breakthrough of this system, which was also independently developed by the Mayans, was the number 0. Older positional notation systems that lacked this symbol would leave a blank in its place, making it hard to distinguish between 63 and 603, or 12 and 120. The understanding of 0 as both a value and a placeholder made for reliable and consistent notation. Of course, it's possible to use any 10 symbols to represent the numerals 0 through 9. For a long time, the glyphs varied regionally. Most scholars agree that our current digits evolved from those used in the North African Maghreb region of the Arab Empire. And by the 15th century, what we now know as the Hindu-Arabic numeral system had replaced Roman numerals in everyday life to become the most commonly used number system in the world. So why did the Hindu-Arabic system, along with so many others, use base 10? The most likely answer is the simplest. That also explains why the Aztecs used a base 20, or vigesimal system. But other bases are possible too. Babylonian numerals were sexagesimal, or base 60, and many people think that a base 12, or duodecimal system would be a good idea. Like 60, 12 is a highly composite number that can be divided by 2, 3, 4, and 6, making it much better for representing common fractions. In fact, both systems appear in our everyday lives, from how we measure degrees and time to common measurements like a dozen or a gross. And of course, the base 2, or binary system, is used in all of our digital devices, though programmers also use base 8 and base 16 for more compact notation. So the next time you use a large number, think of the massive quantity captured in just these few symbols, and see if you can come up with a different way to represent it.
Okay, so with this video, you have learned what are the base systems are. Like, for example, the one most of the students learning math in the computers, they have seen that we have base 2 systems, and in general, we use base 10. That's why we call the decimals. First of all, as we see here, that the division won the competition, and it was the most difficult topic for all of you, similarly as geometry. But the thing is that, like, seriously, if I have been given a chance to formulate the curriculum of this maths world, I would love to introduce geometry in grade 1. Why? Because when we are learning, when we are doing the calculations, and as a kid, when we are just beginning like a toddler, so we used to say, okay, okay, baby, what shape is this? So this shape is rectangle. right? So we learn about rectangles, we learn about circles, we learn about so many things. So this is how we proceed with geometry. And like personally, I really like geometry because geometry is all around us. If I ask you what is the shape of the room in which you are sitting, who can tell me? Let me see the raised hands. I wish I can see the, okay, not, I will see that who is the smallest kid. Yes, Anam Farooq. What is the shape of the room in which you are sitting? Oh, sorry, you are not unable. Okay, can you unmute your mic, Anam, and tell me the shape of the room? Yeah.
A cube.
Very good. Very good. Excellent.
A cube.
Very good. Very good. Very good. So it is a cube in which you are sitting. So why can't we study geometry at a smaller age? We can study at a smaller age because it is something that we can see all around us. Now let's come on to the main topic of our session today, which is English of mathematics. Just like as I said, that it is not very different. The math is just like mathematics, and in mathematics, mathematics is just like any other language of the world. They have their own symbol, they have their own system. Let me just share the screen first, and then we will talk about it. Okay, English of mathematics. As the name implies, that today we'll be reading or studying about different vocabulary that we use in common for uh, just 1 minute. Okay, so today we will be studying about different vocabulary words that we use in English mathematics. So the first thing is that conversion. Conversion means the process of changes from one form to another. Again, this word is very commonly used in in physics, in chemistry, and when we have to do the conversions between the units. So this is very common word. Okay, now we have, after that we have a diagram, again, a very common word that we are using in mathematics, which is diagram. And diagram is basically a drawing which we are used to show a mathematical statement. Now also that we have a drawing and everything, like these small words, sometimes as in vocabulary we know these words, but we are unable to explain it because we don't know that what does it mean. So today we will be explaining or doing the small definitions of these words. Then we have dimensions. Dimension means a measure in one direction, or like, for example, length, width, height, or depth. So if I ask you that what is the dimension of your room, it may be 10 feet, the height may be 10 feet, or approximately 3 meters. And it may be like the width may be some 5 feet or so on. So it depends like in which room you are sitting right now. The dimension means the measure of it in one direction. Now the function. Function, again, we have used it as very common word, and because we have a mixed group of students sitting here, so this word may be a very unfamiliar to the middle grade students or the lower grade students, but as in we proceed from grade 7 onwards, the word function means a special relationship between values. Each input value gives back exactly one value output. You may not be able to understand like lower grade, but I hope it's clear for grade 7 or grade 8 students. Now, perimeter. Perimeter is the distance around the outside of a figure or the shape. So perimeter can be anything. Now perimeter of, you can say the sum of all sides. Okay, now with, I will just ask you one question again here. I'm not good in drawing, but I will try to draw, and I will ask this question to some. Okay, for example, I have a shape here and I will write here, this is 4, this is 2, this is 2, and this is, sorry, this is also 2, and this is 4. Who can tell me that what is the, not the grade 6 and onwards are not allowed to answer. Let me see who can answer. What is the perimeter of this? Yes, right. Yes, right. You can unmute your mic now.
I know there is
12.
It will be 12 because 4 plus 4 plus 2 plus 2 is 12. So what? So we can say that the perimeter of this rectangle is 4 plus 4 plus 2 plus 2. Now, again, as I said, that if our concepts are clear, we don't even want to memorize the formula of the perimeter. We just should know that what a perimeter is. And I told you that uh, it is just a sum of all sides. Okay, whoever giving the answer in the chat, I will see later. Okay, after perimeter, we have congruent. Congruent means having exactly the same shape and size. So we can say, can you just hold the hands together like this? Very good. So my this hand is congruent to this hand because it is exactly same. Does anyone notice any change in both the hands? So we can say our hands are exactly congruent because it is having exactly same shape and exactly same size. Yes, Anam, did you understand this thing? Yeah, I can see you. You can nod your head and I can see everyone's face. So with this, we can say that yes, although it's a very, very difficult word, very complicated word, the word congruent, but any two shapes having exactly same shape and same size will be congruent. Can anyone give another example of this? I will just, okay, we have already so many hands raised up. Okay, who has not answered yet? Ehsan, please write down your full name. Okay, Zain Ejazi, can you please tell me few other examples you can see around yourself which have same shape and same size? Yes, Zain Ejazi?
Nice.
Sorry, say again.
You have to speak. Both eyes are the same.
We can't hear you properly. Can you just repeat, please?
Both of your eyes are the same.
Very good. Very good. So you can see that our body is so symmetrical, mashallah, subhanallah, that our whole body is symmetrical and our legs are congruent, alhamdulillah, our eyes are congruent, our ears are congruent. But what happens that when this word comes in geometry, everyone starts panicking because we are so afraid of this mysterious word, which is congruent. Even we can see that we have grade 6 students, grade 2 students, grade 1 students, but everyone is understanding this word because when we are exploring our body, when we are looking around, we can see that yes, there are many things. Okay, let's because I have asked that I need a few more examples. Okay, yes, Arman Hussaini, can you give any example of being of something you can see congruent around you? Can you please unmute your mic?
flower.
There's so much echo behind you. Can you please answer again?
Flower.
Okay, let me ask. Yes, Qasim. Why Bilal is not answering?
I have two books. They're symmetrical.
They are symmetrical or congruent?
Congruent.
Good.
Same size.
Yes, yes, very good. These two books are congruent because they're exactly same shape and exact same size. Aisha, can you please rename yourself? Okay. Okay, I want other to participate as well. Please raise your hand. The one, Rafat Siddiqui, can you please rename? If you're a student and your name is Rafat, then it's okay. And okay, Yahya Zuhaib, I want you to participate as well. And Zara and Zuhaib Hasnan as well. I'm going to ask you questions, so listen carefully. Okay, so although you can see that we know that congruent is a word which will be studied in grade 7 maybe, but being a grade 2 or grade 3 students, we have understood that having exactly the same shape and size is congruent. Okay, now let's move on to that expression. Expression is numbers and symbols grouped together to show the value of something. Again, for small graders, it may sound very weird that please keep your mic unmuted. Okay, now you can lower your hands after answering one question because so that we can do other. Okay.
आपको फोन नीचे गिर गया था
इसका फोन और
Okay, now we have like for example, if I want to explain expressions, so for example, I have on the table of Qasim, I can see two books. Do you have any other thing on your desk, Qasim? If I can see, because I can see your video. Do you have any other thing on the desk? Can you show us, please? We have two books, and do you have pencils around? Okay, let's suppose Qasim has got two books and three pens. Okay, now again, this topic is related to algebra, but is it very difficult to say this that we have two books and three pens? Believe me, this is an expression in algebra. What can I do that books, I can have a nickname of books as B and 3P. 3B plus 3P, this is an expression. Okay, now let's see. I ask you one more question. I will type the text here. Let me see if you have understood or not. For example, I can say that we have one speaker right now and 42 participants. Who can write the expression of this? Who can write the expression for this one? Let me see. Who has not answered yes? Yes, Sumaya Sheikh, can you please tell us the expression of this statement?
It will be 1 plus 42, and that it will be 43. The answer.
Yeah, but right now you cannot count me as participant. Speaker and participants are separately. If I'm speaking, I'm the speaker. You are the participant. Okay, so who can just, there is a one mistake here. Yes, Abdul Rahman Faisal. Can you answer? Please speak louder.
1S, 1S, and 4 participants.
Only four?
42 participants.
But we don't like this word participant. Can we have a nickname of it?
P. 42.
Very good. Okay, now my answer, and I will ask Zara and Zuhaib Hasnan now. For example, on the table, I have 2 apples and 4 oranges. Who can tell me the statement for this? I will ask one after this. I will ask Zara and Zuhaib. Okay, I will ask. Okay, Sumaya, you just gave the answer previously wrong. Yes, Sumaya, can you just fix it?
Yes, it is 2A plus 4O.
4O. What's your grade?
4.
4. Okay, now have you studied algebra before?
No.
No. Okay, so 2 apples and 4 oranges. Now this is from where the algebra begins. So we have on a table that we have 2 apples and 4 oranges. Now Zohaib Hasnan, can you please tell me that can you add 2 apples and 4 oranges? You can unmute your mic. Okay, if you add 2 apples and 4 oranges, what should we call it as? Can we call it as 6 apples?
Can I say?
6A.
Can we say 6 apples?
No.
Okay, can we say 6 oranges?
No. Can I say?
I don't know this person. No, I will ask only with the raised hand because I want to.
My hand is raised.
But who are you?
I'm Sayyid Saqib Nuri.
Okay, Saqib, please answer.
You can call it 6AO.
I can call it 6AO. Okay, no. Okay, Fatma Nadeem. Fatma Nadeem, can you unmute your mic if you know the answer? Yes?
Yeah, 6A and O.
No. Actually, we cannot add them. And the answer is exactly same, that 2 apples and 4 oranges. Because they are different, they are different quantities. We cannot add them. Okay, so it's okay because all of you are from the lower grades, but we cannot add apples and oranges together. Just like that I have given you the example here, like 1 speaker and 42 participants, we cannot add them. Let's move forward to our other things. Okay, 1 minute. Okay, just give me a minute. Let me see the, okay, let me see what is in my chat first. Okay. Um, Very good. 2 pillows are also congruent and good. Very good, Zaina Jazi, that we cannot add them because they are different units and they are different quantities, so we cannot add them. But you can see that this is all the algebra says, that when we started using the things in our things from the our real life things, then it is very easy and very we can just introduce algebra like this. Okay, so you don't have to be afraid that whenever you will be introducing with algebra or the pre-algebra, please do not be afraid and start liking it. Okay, inequality. Inequality, a mathematical sentence that uses symbols such as, you know, the symbol of inequality. So when something which is unequal, this is called inequality. Then we have the averages. Okay, again, this is for higher grades, that a measure of center in a set of numerical data, computing by adding the values in a list and then dividing the numbers if values in the list. Okay, now I would like to explain this this small topic, which is mean. So mean is not that mean that, oh my God, you are so mean. Is it this mean? No. So mean is something which we can call as in a common language that it is an average. Like for example, today is Friday. You can all lower your hands because I will explain it first and then I will ask you a question again. And maybe these topics may be not very like this topic may sound very simple for higher graders, but this is not about knowing something. This is about developing the interest of math. Okay, so today is Friday. On last week, starting from Saturday, you used 2 hours of for example, Xbox, or you can say like screening. Okay, now let me ask everyone how many hours they think that they have used the laptop or iPad or anything on Sunday. Okay. Yes, Bilal, are you there? is Bilal? Yes. Yes, Bilal Saqib, are you there? Okay. Aisha Adil, how many hours you have used the phone or laptop or screen on Sunday?
1 hour, 3 hours for
3
a
hours.
class.
Okay. On Monday. Okay, Fatma Junaid, how many hours you have used the screen on Monday?
4.
4. Okay. Tuesday. Yes, Afsari Aziz Ahmed, how many hours you have used the screen?
Around 4 hours.
4 hours. Okay. Lisa, how many hours you have used?
Can I answer?
Yes, Lisa? Yes, Lisa? Okay, Ibrahim Danish, how many hours you have used on Wednesday?
3 or 4 hours.
3 or 4 hours. Okay, let's assume that everyone has used 2 hours on Thursday and Friday. Okay, today is Friday. And yes, Maha, how many hours you have used the screen on Friday? Last Friday. Yes, Maha?
नहीं भाई खुद करो, help yourself, move your ass बेटा.
Okay, maybe on Friday.
3 hours.
Okay, 3 hours. Now, to find out the average, or to find out like how this is the data we got and why it is important. Now I'm telling you the importance of statistics, that because we have different data coming up on the screen, so we can say that 2 plus 2 plus 3 plus, sorry, 2 plus 3 plus 4 plus 4 plus 3 plus 2 plus 3. And how many days are there? There is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 4, 3, 2, 3. So if I divide this by number 7, we will get the answer like how many days you have used screen, like what is the average number of hours you have used the screen on the day. So do you have calculator? If you have calculator, just add the numerators and divide by 7. Just do it on your calculators. Okay, let me see who have raised hand. Okay, Fatma Hassan. Do you have calculator?
No.
Yes,
I know the
Adnan
answer.
can leave the meeting and join again.
Excuse me? Did you say divide by 7?
Yes, divide by 7.
Can I answer?
Can I see the answer?
No, I will
Can I
select.
answer?
No, I will select myself. Yes, Ibrahim Junaid.
It's 3 hours per day.
Is the answer coming 3? Okay, let me check. 5 plus 5, 10, and 10. How is it coming? 5. What you said? Okay, 3. Did you say 3? Always calculated then. Okay, so we have so this is the importance of finding out mean. And again, the ones who doesn't know the stats, who doesn't know the average or doesn't know the mean, even they can know just by knowing that what actually a mean is. Okay, I hope everyone has understood, because we have a smaller grade as well, so it may be something. Okay, it may be something like. Okay, after mean, we have again a short YouTube video. So I will just I will just play it in a while so that we don't lose the interest and we move on. Okay, just give me a minute, please.
You are muted.
Yes, I know my mic is muted. I'm just need one more minute to play the video. Just 1 minute, please.
Okay.
Okay, I'm starting a video here and I hope everyone will enjoy it and it will be very informative to all of you, even the senior students. Okay, I'm sharing my screen and let's see 20 facts about numbers that will make you feel like a mathematical genius. So I was thinking to speak and rather than this annoying music. So do you know that zero is an even number, and we have that there is only one number spelled with the same number of letter itself, which is four, because four has got four letters, and it is four. And then we have six is the smallest perfect number, because in the number perfect number in the number theory we can say that by a positive integer that is equal to the sum of the positive divisors. So 1 plus 2 plus 3 is 6, and also 1 multiplied by 2 multiplied by 3 is also 6. So this is 6 is a perfect number. And of course, you can just note down some things from this slide. Of course, it is available on the YouTube, but you can ask your parents as well that you have learned so much today in the today's class. Okay, then we have another coming up that okay, now regarding pi, that you have to listen, you have to read it very carefully. That a pi is a number. A pi is a number which is the ratio of circumference to the diameter of a circle, and it is an irrational number. And there is a day which is designated to the pi, which is 14th March. So this is another number, and now the lower graders can ask your parents at what pi is, and they may answer you maybe an apple pie or a cheese pie. But in mathematics, pi is irrational number. Then we have, okay, this is very interesting. Let me go back a bit. Okay, 2 and 5 are only prime numbers that end with 2 and 5. So prime numbers are the numbers which can be divided by 1 and itself. So any other number ending with 5, like for example, 25, 35, 45, they are not prime numbers. Only 2 and 5 are the prime numbers which end with 2 and 5. Then we have, okay, so do you know that 9 is considered a magic number? Why? Because you might have seen a lot of calculations regarding 9, and it is called a magic number. And because it's a very long video, I would like to teach you some tricks now. So are you ready with your pencils and the papers?
Yeah.
Okay, now please do not unmute your mic unnecessarily, because there will be too much noise here and we won't be able to understand. Now today I'm going, of course you might have the calculators as well. Can some of you please open up your video so that I can see you as well? I think every video is okay. Now we have, let me tell you the trick for 11. Okay, 11 multiplied by 2 is 22. We all know that, and it's very simple. 11 multiplied by 3 is 33, and we all know this. Now let's do one thing. 11 multiplied by 12. So the trick is that write down 1 and 2 with a space in between. Add 1 and 2 and write 3 here. 11 multiplied by 12 is 132. Are you getting this answer, guys? Can anyone raise the hand and verify my answer with the calculator as well? Yes, Zara, what is your answer? Am I correct?
Yes, you are
Zara,
correct.
sorry, say again, please.
Yes, you are correct.
Thank you so much. Okay, now let's do one more. 11 multiplied by 32. So we will just write 11, and this only work with 11. Okay, this is the trick for 11. So we will write 3 and 2 with a space, and 3 plus 2 is 5, and we will write in the middle, so it is 352. Yes, Mohammed Ahmed, do you want to say anything? Yes, Sumayya, am I correct?
Can you explain again?
Which this thing?
Yes.
11 multiplied by 32. Okay, I have written 3 here and 2 here, and 3 plus 2 is giving me 5, and I wrote it here. 3 plus 2 is 5.
Ma'am, yes, this is correct.
Okay, but did you understand the method?
Yes, ma'am.
Good. Okay, now let's do one more and then we will move back to our slides. So 42 multiplied by 11, sorry for my bad handwriting. Okay, 42 multiplied by 11, it is 4 and 2, and 4 plus 2 is 6. So I get 463.
You are correct, miss.
Thank you so much. Yes, Aisha, am I correct?
It's a very good method.
Did you like this? Raise your hand who find it very
It's the
easy.
easiest method.
Very nice. So you can, even if you don't have the papers, you can do this mentally, okay? Now for again, I will do one more. Let's take 52 multiplied by 11. So we have 52 multiplied by 11 is, sorry, 572. Who said this? Who is me?
Is this
Very nice.
only for 11?
It is only for 11. Yes, it is only for 11. Okay, this is strict for 11 only. Okay, so do not confuse it with other numbers. Okay, now let's move back to our main slide. Just wait a minute. Okay, now we'll go back to our main slides, which I don't know where it is. Let me check. Okay, so here we have for the probability we have that okay, again it's a very a topic which is studied in higher grades, but it means that how likely it is for even to happen, which means that, for example, what are the chances if it is, yeah. Okay, for example, if you have not understood the 11 trick, I will try to explain you individually because we have to move on to our presentation. So for example, if there is zero chance of happening an event, if for example there is no chance of happening an event, it is the probability will be 0, and something which is 100% to occur, the probability is 1. So for example, if I ask you that what is the probability of raining, anyone from Karachi here? Can anyone lower your hand and, okay, anyone from Karachi here? I mean, right now in Karachi. I mean, not in Jeddah. Right now in Karachi. Anyone from Karachi right now?
No.
Okay. Okay. What are the chances to rain right now in Jeddah? 0 or 1? 0. Okay. What are the chances that you will meet Imran Khan right now?
0.
0.
0.
0.
Okay. What are the chances? What are the chances that you will see the next slide now?
1.
1. Okay.
100.
So again, that this topic looks very difficult. Okay, please keep muting your mic after answering. Keep muting your mic. Thank you so much. So even after this topic is again a very higher level grade question, but still you are able to answer it because you understood what is going to happen. Okay, we can have a 0.5 probability as well, that it is between 0 and 1, that something may happen or something may not happen. For example, you might get your mom orders a pizza right now. Is it a 0.5 chance?
Yes.
Okay. Who is 100% sure that your mom ordered a pizza now? No one?
No one.
No one. So sad.
No.
Me.
You?
No. 1%.
1% or one probability?
One probability. One probability.
You will get a visa right now? That's great. Do share with us. Okay, next move on to the other slide and let me see. Okay, rational numbers are those numbers which can be written as fraction. For example, 2 over 3. So 2 over 3 is also a number and which is called a rational number. For example, 3 over 4, this is also a fraction and it is called a rational number. Please unmute your, mute your mic. Please mute your mic. Okay, for example, if I have 2 over 5, these all fractions, like all grades must be studying it, and these are called rational numbers. Okay, now we move on to other topic, which is circumference. Now, circumference is the distance around a circle, the perimeter of a circle. So any circle, and for example, I have a circle, and if I measure it all around it, it's 5 meters. So the circumference will be 5 meter. Okay, now we are running out of time. So we have this thing, like these are on the screen, these are called brackets. We can have curly brackets and we can have square brackets. We have equality. Equality means is equals to signs. When you can see two curved signs, this is approximation sign and it means approximate. Like for example, if I ask your age, if you are 6 years old, but you are not, if anyone is having birthday today, then you can say that, yes, today I am 6 years old or today I am 8 years old. But anyone right now, if I ask your age, that will be your approximate age. So this, you can note the sign here that this is an approximate sign or these two curly ones. Not equality means unequal or inequality, then you have a line between equal sign. Greater than, it is something like this, you all know that, and less than like this. Then we have asterisk. If you are on the keyboard, you can see this shape, this symbol on above the number 8. Asterisk is the name of this symbol. Caret is a symbol which is on number 6. And if, for example, if I want to write x, please mute your mic. If we have x square, so I can also write it as x caret 2. Okay, so this is the symbol which is called caret. And we have addition, we have subtraction, we have division, we have parentheses. You all know this.
What is parenthesis?
Okay, please mute your mic. Okay, now moving on to the next slide. We have all these symbols. We have a semicolon, colon, percentage signs. We have hyphen sign. And most of you don't know this sign, which is ampersand sign, which is like this. We usually use for and this sign is called ohm sign. So it's semicolon, colon, percentage, and hyphen, and ampersand, and ohm sign. Then we have invisible maths. This slide is very important, that we have multiplication signs. So if we are writing A and B together, it will have a multiplication sign. If we use a dot in between them, again it's multiplication. If we have A bracket B, again it's a multiplication. Now, if there is any number raised to the power 0, any number to the power 0 is equals to 1. Then division signs, you can see that division can be written as A divided by B, A slash B, A over B, and so on. This is division sign. There is a denominator. If there is no denominator written and there is a whole number, there is always a 1 for every number. These things that I'm explaining right now, it's very important for grade 5 onwards. So please listen very carefully. Now, if there is this is invisible math, that we do not write it. Okay, so there is a decimal point at the end of every whole number. So this decimal numbers cannot be seen, but we can have this decimal point is after every whole number. So every number has an exponent of 1. So every number has got 1 as an exponent. Okay, if there is a number written like here, 6, I'm talking about this one. So this is 6 and there is a positive sign to the left of every number. And if there is no coefficient written like here in this pink chart, so there is always be a 1 before it. And so on. There are many invisible maths, and I will definitely share these slides and these images in the group. Okay, let's move on to the next slide. This is almost the same thing. Just let me check if we have ended. Okay, so this was the end of the slide, and you might have understood most of the things because there was a mixed group of students attending this session. So there may be some up and downs, but it's okay. Right now, we want to develop the love of maths, and here we are. We have a quiz right now, and I would like Ibrahim Junaid to send me the link, or we want to. Okay, Muhammad Ahmed, did you understand everything? Did you like this?
Yes, I'm sending the link now.
Okay, where are you sending me on the group? Muhammad Ahmed, are you here? Yes, can you unmute? Yes, Muhammad Ahmed, did you like the 11 trick? Multiplication by 11?
I like it.
Okay, if I ask you a question that 11 multiplied by 13, what will be the answer?
143.
Good. 143, right?
Yeah.
Very good. Excellent. I'm really proud of you, Muhammad Ahmed. Okay, now I'm sure. Okay, the quiz link has been shared in the link, and okay, Ibrahim, just start in 2 seconds. Has everyone got the quiz? Good.
Yes.
It may be difficult for someone, it may be easy for someone, but it's okay. It's just it's just participation. There is no winning or losing the game. Okay. I will also.
May I just say the rules?
Yes, please.
Okay, so when you click on the link, you'll be prompted to the screen where you have to write your full name. Once you write the full name, and once everyone joins the quiz, I will start it, and then we can view the leaderboard as well.
Can you please repeat?
I was saying that once you click on the link, you'll be brought to another page or another window where you can enter your name, and then you'll be brought into a waiting room. And then when I start the quiz will begin. And could you just make me the co-host so I can share the screen as well?
You can share the screen. I did it. Okay.
Should we press the link?
Please join the quiz now. Tuba, do you want to take the quiz? Amal, are you doing it? It started? Are you sharing? Will you share the screen, please, Ibrahim? Yes, Ibrahim. Okay.
Yes, I'm sharing the screen now.
Okay, let's
okay,
see. So everyone has joined. You have not started, right? That's great. So can we start now?
Yes, let's start.
That's great.
Starting now.
5, 4, 3, 2, 1. Very good. Guys, you can guess as well. There is no hard and fast rule. There is no winning. There is no losing the game. It is just the thing that you are just playing and participating and having fun and having the feeling of liking maths now. I will ask you in the end that how much you have loved maths now. I can see that the higher grades are getting more score, but I will not count them. Don't worry. I can see the ones with the lower grades. I will consider them. Of course, there is no winners, but of course, but very good going. How many questions are there, Ibrahim?
There are 20 questions in total.
Okay. Thank you so much for making this quiz. It looks very interesting.
You're very welcome.
It's okay if you're getting the wrong answers. It's okay. Okay, so do not be disheartened. It's your courage of participating in this quiz. It's not about winning and losing at all. Who logged in by the name of Pizza? It's very interesting. Yes, Maham and Anam, you have not started the game. Can you scroll down? Yes. It's okay. Very good. So Afsari has already done that. Amal has finished. Arisha is about to finish. Yes, Arisha. Who else has done? Scroll karna niche, Ibrahim.
Sorry, did you say something?
Can you please scroll down?
Sure.
Good. Just finish it quickly and inshallah we'll finish up the lesson as well. Yes, Maha. Good going, Bilal. Okay, Zara and Zuhaib has also finished. Very good. And Sumayya Sheikh has finished. And that's the courage, that's the spirit that you have taken this exam or the quiz, whatever. It's not your exam, it's just a warm-up exercise for all of you. Ali Faizan has finished, Fatma Junaid has finished, and Qasim Furqan has done, Fatma Aziz Ahmed, and okay, she's still doing. Fatma Hassan has done, Lisa Nadeem has done, Maha has done. Yes, we'll wait for everyone to finish. 2 minutes more. We have the time limit, right?
Yes, we have a 10-second time limit.
Okay.
For each one.
The one with most incorrect answers will be the winner. Now let's see. Scroll down. It's okay. So Ali, Maham, Anam, Zara, and Zuhaib, and the pizza looks the winner so far. It's okay. It may be difficult because we have a lot of younger kids here, but it's perfectly okay. It's just a warming up exercise for all of you. How much time is left, Ibrahim?
It depends on the people playing. Depends on the questions they have left.
Maham, can you log in again? For Maham, it's not.
I can end the game whenever you.
Okay, we can wait.
Yeah, okay. We just reload the site then.
Okay. Please do not end the meeting. Why it's not working for someone? Did you stop like the joining connection thing, something?
No, you can join at any time. It might be that they might be having a server issue, maybe. You could just join again using the same link.
Okay. Okay, Zara and Zaib say that they made 2 accounts. It's okay. It's okay. So you can keep on doing. Actually, there is. It's okay. It's okay. Thank you for clarification, Zara and Zaib. So here we have ended our class, and is it done? Should we end? Or 1 more minute? Let's have 1 more minute. It's 5:15, and whoever wants to finish it up, please do it quickly. Very well done, Bilal Saqib and Rumesa Saqib and Hassan Abdul Jabbar, Ahsan Nazar, Khizr, Maha, Zara and Zuhaib Hasnan, Ayan. Okay, you can stop the quiz now.
Can we leave the meeting?
No, you don't have to leave the meeting right now. Just leave meeting in 2 minutes. Okay, can you stop sharing the screen? Just take the screenshot of these scores and then.
Okay, should I end the game?
Yes, please.
Okay.
Okay, so with this, we came to an end to our interesting math class. And I hope you have enjoyed today's class. Now, quickly tell me that, do you still hate or love math? So for those who just still hate math, raise your hand. So Ibrahim Danish doesn't like math, Maha Shehzad doesn't like math, Arman Hussaini doesn't like math. Okay, for those who just love maths now, please raise your hand. Very good. Very nice. I really love you all, and I hope you have enjoyed the session. And keep loving maths, keep motivating yourself to learn maths and do wonders in maths. Be mathematicians, and I wish you a very good year of your school starting from next week. So hopefully you will get good scores in maths next year, inshallah ta'ala. So I'm signing off now, and thank you so much for attending the session. I hope you have really enjoyed. So see you inshallah with some new topic someday. Thank you so much. Allah Hafiz.
Thanks for teaching me.